When a population consists of numerical scores from an interval or ratio scale, and usually we'll basically assume ratio, it's customary to draw that distribution with a smoothed curve instead of, say, a jagged histogram. The smooth curve indicates that you're not connecting a series of dots, but instead are showing the relative changes that occur from one score to the next. And most often you show a smooth curve that's normal, or we'll assume that it's normal. For instance, here. And I'm reluctant to talk about IQ scores all the time. You'd think that IQ scores are the only thing that are normally distributed, and of course, that's not true. But this is what's often known as the bell curve. And in this curve, whether we're talking about IQ scores or needles on evergreen trees or heights or weights of people or body temperatures, is generally normally distributed, which means there are a lot of scores around the mean, and that's what we show there with the relative frequency, and then very few out in extremes. So with IQ scores, of course, there are very few scores at 130 and very few scores at 70, which are plus and minus 2 standard deviations from the mean. Conversely, there are a lot of scores that are packed in toward the center. So implied in that are columns as though it were a histogram. You can imagine a big, tall stack of scores at 100 and a big, tall stack of scores at 100.1 and a stack of scores at 100.2. The further we get from 100, the shorter the stack's going to be. Once I get down to 130, of course, it's a short stack of scores that are exactly 130. And a short stack of scores that are 130.1. When I go over to 70, a short stack of scores that are at 70, an even shorter one that's at 69.9, etc. If I stacked all those tiny columns together that run together with common upper and lower real limits, and I might go even to a finer level than 0.1, like 130.01 or something like that, it would eventually take on the appearance of a smooth curve. All of those heights of those columns would appear to take on a smooth shape as they descend and ascend, as they slope upward and downward, and that's what we would arrive at with this smooth shape. Now, again, most things that we'll speak of are normally distributed, as are things in nature. So, for instance, it's always an absurd example, but I think of evergreen trees that have needles. How many trees or needles are on an evergreen tree? Maybe it's 200,000 or something like that. So if I had a mean of 200,000, is there an evergreen tree out there with 300,000 needles? Well, yes. Is there one with 50,000 needles? Yes. But I could draw a sloping graph like this where each value is listed continuously, and the height of those values would be the mean, which is 200,000 needles, which is a crazy thing to say, but nonetheless, that's what we might assume to be true. Now, there are different distributions that are smoothed over like this. On the left there, you can see we've already talked about the smooth curve that's normal or symmetrical or a bell curve. There's also a symmetrical distribution that has two humps, if you will, and these humps are known as modes. So maybe it's the case that I have found out that people are most likely to get traffic tickets at age 25, and then again there's a peak at 55. And those two modes are depicted there. And what we mean by mode, of course, is the most frequently occurring scores. Now, there might be a tie for that, and essentially that helps me understand the two humps in the graph. We also have skews, and skews are less likely or less common than normal distributions. If scores tend to stack up on the low end, and remember, on the x-axis, we go from low values to high values, left to right. On this skewed distribution, I might have low values here and high values over here. Is there anything that we can think of that's positively skewed where the values stack up on the left? And yes, that might be income. Here in the United States, we have a lot of people that make modest incomes, and professors would be in that group. So yes, we have positive skews with scores stacking up on the left, income stacking up on the left that are modest. But don't we also have gigantic income earners? Sure. Zuckerberg, Bezos, professional athletes that we can think of, Oprah Winfrey, etc. All of those people have 9-figure incomes, and they're a part of these smaller stacks. Do I have people that make 100 million? Yes. Maybe that's right here, but it's a very small stack of people. Do I have people that make very modest professor type incomes? Yes. And that's a large stack of people. Conversely, let's take a negative skew where the scores stack up on the high end. Here are low scores and here are high scores, and there are more scores on the high end. What might that be? The example that I've always thought of has to do with driving test scores. When a 16-year-old comes to take that test, they are, for the first time, presented the opportunity to be liberated from the household. They can go run errands, they can meet their buddies, and just get out of the house for a few minutes. And most are motivated to pass their driving test. And I would imagine, although I've never seen the statistics on this, I imagine the great majority of test takers have pretty high scores on their driving test. I would just assume that that's true, because it's such a they're so strongly motivated to get that driving license. Now, might there be some that flunk the driving test? Yes, maybe just because of complete unpreparedness or having a case of nerves, or they're ambivalent about driving. They don't want to get their driver's license because maybe they're afraid their family will take advantage of them running them too many errands or something like that. But positive skew, the scores stack up on the low end. Negative skew, they stack up on the right end. So in any case, all of these graphs depict implied histograms. I've got a column here, a column right next to it, a column right next to it. And when I have just scores and scores and scores of skinny columns depicting individual continuous values, it takes on sort of a smooth shape when they descend and ascend.